All right, welcome to video number one to help what we're doing. So, first one is a linear pattern. And so, what are some patterns that we've done before? Was this at the beginning of the year, this U cubed one, where we said, how did this pattern grow? And so we had different interpretations of how this pattern grew. So, like the first one, this one was more like that. It was kind of like the rainfall, right? We just throw them on there. And as you can see, as you go on further, right, you threw on 5 more for this case, and then for the next one you threw in 7 more, and then 9 more. So that was one of the examples that we did. Now, what about on another example? Because again, this is one more than interpretation of looking at these patterns. Was some of us thought, well, instead of looking up and down, we looked at that left to right, and so this one kind of split. It became 2, and then we added a new row, and then that row split, and then we added that new row to the next one. So this is where we kind of ran into this pattern, and so we wanted to see, well, is this pattern linear? Are other patterns linear? And what we saw for this pattern was that this one was 4, then it went to 7, and then it went to 11. And so, and if we actually go back, the next one, this would be 1, just 1 square right at the beginning. And so if you look at this pattern, if you want to say X and Y, all right, the first one was 1, the second one was 4, the third one was and it was at 7. And actually, I messed up. So the second one wasn't 7. It was 3, 6, 9. Sorry about that. This is not 7. This is 9. So it's 1, 1, 2, 4, 3, 9. This is actually 9. Sorry. And then the fourth one was not 11. If you add that up again, 3, 6, 10, 11, 12, 16. 16. And so is this pattern linear? We said no. Why is it no? Is because it's not going by a constant pattern. Is there a pattern? Yes, it's +3, +5, +7, but this is not linear. Why? Because it's not adding the same value. Okay, so when you look at those patterns here, you need to make a table for those, and then just like what it asked you to do, is say, is that pattern linear? Okay, so explain in words why it is not linear. So use that shape in your explanation as well. So trying to see why is that not that constant rate of change. It actually asks you also to draw the next 2 pictures as well. So maybe even show in your drawing how does the figure change. And so this one was not linear, so let's show an example that was linear. So in this case, this was one of the problems we did in class that was linear. And so if you look at the first figure was this figure, right? And so the first one, if you want to say that, again, just using X and Y, which is X is the figure number, Y is the number of blocks. So the first figure number had 3 blocks. All right, the second figure number had 6 blocks. Okay, the third figure number has 9 blocks. Okay, and so now we can see this linear pattern change. Because why? Because now it's going by that constant rate. And so what you're really finding in all these is the slope. All right, so this is +3, +3, and so our slope is 3. And so if there is a slope, then it is linear. So in this case, this is linear. So that should help you out on the first one. So again, color, make those next pictures, make a table, and then describe, just how I did verbally, but you have to describe in words, why is that pattern linear or not linear, and try to use that pattern in there. So you can even see that this is a constant rate because you're adding 3 more blocks, 3 more blocks, 3 more blocks. So to try describe in that picture why it is linear or why it is not linear. So the next one we went into is, okay, so we know this rate of change. How can we expand it using the rate of change? And this kind of helped us introduce or really solidify our second understanding of the 2 concepts that you have to understand to be successful in linear equations. So the first one is slope, right, that rate of change. But the second one is what introduced in this problem. So what we did is we put this weight, right, we watched this video, and by far, most people said what's the next weight, right? So we said 10 is 350. We said 20, and by far most people thought this was 700. Okay, because they just doubled 10. And so what they forgot about was the start value. And so if you look at the scale, right, we see the scale, it starts at the weight of the cup. All right, so in this case, the weight of the cup is that start value. And so we found out that 20 was actually 400. And then now we can see that pattern is when we add 10, we add 50 grams. So for 30 marbles, this would be 450. Okay, so for 30 marbles, that would be 450 grams right there. So we saw that rate of change was 50. And then some of us wanted to make the slope saying the slope is 50. And if you go backwards, right, what's 0 marbles, right? If you go back 50, 0 marbles is 300. And what is that 300 is? That 300 is the start value. That's our y-intercept, our start value of 300. And what does this cause? So we had really some good discussions, right? And Lizzie, or Izzy, I'm sorry, is the expert in this, saying that that again, we have to have that start value of moving around that start value. And so if it does not start at 0, so in this case it starts at 300 when there's no marbles. So this is marbles, we'll say x and y is the weight. It starts at 300. What does not work is this is what's called not proportional. Why is that not proportional? Is because you can't double you can't double this, right? It's not 700, it's 400. You can't double this up to get the next value. So this is what's called not proportional. And so that means you can't do that, as well as you can't just multiply the slope. So let's say, what's the 10th one? What a lot of people do is just like to say, well, it's 50 times 10. And they would say it's 500. And actually, we actually made a slope mistake in there is also assuming the slope is 50. Because actually I messed up on this x as well, so again I make mistakes, is this is not 1 marble, it's actually 10 marbles and 20 marbles. And so we need to actually find our rate of change also before we even worry about the start value of what's that per 1 marble. And so we have to take this 50, change in our y, and divide it by our change of our x so we can find it for 1x. And so this is 50, the black, and then the blue is the change of 10. And so we take 50 divided by 10 to find 5 grams for 1 marble. And so then what is our equation, right? So our slope is 5. Our start value is this 300. And so, and try to put a different color here. This is 300. And so our equation is y equals 5x plus 300. And so this would help us expand our pattern. And so now when we go back to this table, and let's say we want the x is for, let's say, 75 marbles. Well, how do we find that 75? We have to take that 75 times 5, because each marble weighs 5 grams. And that's, trying to do that in my head, 375. Now that's the mistake, is tons of people just put 375, but again, it's 375 plus 300. We started at 300, and so we have to add that 300 in. It's 300 plus 375, and so for 75 marbles, it's 675 grams. So when you look through that marbles, and again, each one of these has a different start value. The weight of the cup is different. So the first one, you're given the weight of the cup. The second one, you're not given the rate of the cup. But in each one of those, you're not also given the rate of change. So the first one, you may think the rate of change is 20, but the rate of change is not 20. All right, it's 20 changing for 10 marbles. And so for that first one, you have to take 20 divided by 10, and your rate of change for the first one is 2. All right, because 20 divided by 10 is 2, so it's 2 grams for every 1 marble. So again, explaining what that is as well. So again, you have to divide the change in y over the change in x to find out how much you're changing for y for 1x, because the slope is always the change for 1x. And this is also saying why is slope so important is because unit rate is so important. And as 7th graders, you should have done a lesson on which problem is the most orangey, or which place should you see when you're eating pizza, of looking at the unit rate. The unit rate is really important on what's more on understanding and how to solve problems, and that's the same case here. Is that 50 per 10 is useful, but What if you wanted to find 75, right? It's not going to help you to know that 50 grams is 10 marbles, right, to find 75. Or what if we wanted to find 116, right? Well, if you know 50 grams is for 10 marbles, that's not going to help us find X is 116 or when there's 116 marbles because we only know what 10 marbles are. We don't know what one marble is. But once we know what one marble is, then it's a lot easier to expand. But you cannot remember, again, do not forget about your start value. Okay, so for all those, do not forget about your start value. So divide, find your slope, okay, and then you multiply by your slope, and then add your y-intercept. Okay, so, and again, write that equation as well to get you in that practice, as well as just showing that you're understanding what the slope is and understanding what the start value is. And again, the slope is always harder to find. So this is the help video for the first couple problems. If you have problems on the next couple, please watch the next video. But we're just going to break these up into 2 different videos. So hope this was good. Thank you.